Now, in previous lecture, we have seen the importance of higher order modes, their manipulation and their applications in generating higher bandwidth using mode merging technique and obtaining higher gain on higher order modes. How it is being developed? Let us take an example of rectangular DRA which has x-axis, y-axis and z-axis plane. Now, if we plot Zn on y-axis, that is current density, and take wavelength along y-axis and then develop the half wave variation along x-axis at say certain point 0.5 Jn value. These are also known as eigenvector versus wavelength graph. What we see, if represent J1 as number of half wave variations along the wavelength, we denote this as a J1. Then we take number of half wave variations along wavelength as 2. We will represent this as J2. The third case, we take the number of half wave variations are 3 along wavelength, that is x-axis, so we denote this as a J3. It means if we see in this graph eigenvectors versus wavelength, there are three parameters. One is J1 where number of half wave variations only 1, then J2 where number of half wave variations are 2, then J3 where number of half wave variations are 3. Now, if we take a slab of rectangular DRA which is cuboid in nature, it has a dimensions of x, y, z. Here x is x-axis, y is y-axis and z is along z-axis. So it means this slab of DRA has some width, some length and some height. So we will see these the resonant modes are nothing but field formats developed by currents. So we want to decode what is the format of currents being developed when number of half variations along x-axis is 1, when number of half wave variations along y-axis is also 1, when number of half wave variations along z-axis is also 1. So we will say that these field, on surface there is a field pattern being developed or field format of E or H is being developed. We will call this as a particular mode being excited. Either it can be T mode or it can be TM mode. So coming back to the example which we have taken just now, that along x-axis, along y-axis and along z-axis, the number of total half wave variations are only 1. And if we are we are taking a field pattern of T mode, then we will recall that this is a mode excited into rectangular DRA as TE111. Now, if we switch from J1 to J2 configuration, in J1 there was only half wave variation, in J2 we take 2 half wave variations, in J3 we take 3 half wave variations. So I now switch from TE111 to a next field format that is known as field pattern as TE121. So in this case, the first one will represent number of half wave variations are 1 along x-axis, and here TE12 represent that number of half wave variations along y-axis are 2, and third TE121, third one represent that along z-axis the number of half wave variations are 1. So similarly, this is in our hand. Either we want to take plot of H field or E field, and E and H both are orthogonal to each other. So this generation of resonant modes can be cited using field pattern or electric field pattern being developed into a DRA. So depending on E field or H field, we can define that which mode is being configured. Then In the next lecture, we will see that how these modes are being rotated or modes are being oriented. These modes can be oriented using polarization. That we will take in the next lecture. That's all.